The natural orifice transluminal endoscopic surgery is one of the surgical techniques of minimally invasive surgery introduced in 2004. Unlike conventional abdominal open surgery and the current dominating laparoscopic minimally invasive surgery, where incisions on the abdominal walls are always required, NOS is a scarless endoscopic procedure that gives access to the surgical site through body's natural orifice. This operation causes less damage to the patient's body and enables faster recovery. The NOS procedure was performed with a flexible endoscope which passed through the natural orifice, and a flexible band manual instrument introduced in the endoscope's channels. The direct operation of the endoscope and instruments are difficult and complex, which require at least 2 professional surgeons to perform their perfect coordination, but in limited workspace and tiring postures. The multiple robotic systems have been developed to enable a surgeon to telemanipulate the flexible endoscope intuitively. The complex operation of scope and synchronized movements of both hands were simplified to one hand or multiple fingers operation. However, most of the current robotic endoscopic systems are still designed for hand control, and only 2 instruments can be controlled together by one surgeon. When controlling 3 surgical instruments, 2 skilled persons are still required. In general, there are several operation strategies to control 3 surgical instruments in the current practice of endoscopic surgery. One is still using the cooperation of 2 surgeons, like master system of our group. One surgeon is controlling the band manual instruments through teleoperation, and another endoscopist is standing at the patient side to control the endoscope. The communication error between them are inevitable, especially for novice assistant or new team. Another way is using separate hand interface to control the third instrument, all using the same hand interface to control different surgical instruments by pressing clutch buttons or pedals to activate the swapping. These control strategies are using sequential band manual cooperation, so it's not possible to move the endoscope and instruments at the same time. Hand-free control provides another solution to let surgeon control 3 instruments. We can find examples in robotic laparoscopic system with rigid instruments. The hand-free sources like head, finger, foot, eye gaze are used to control the laparoscopic camera. Among all these control sources, foot is a potentially reliable solution to control an endoscope to work together with hand-controlled instruments with less interference of the hand operation and visual feedback. Doing this work, we used foot acting as surgeon's third hand to control the flexible endoscope. A novel foot-controlled teleoperated robotic system was developed. The system collects natural foot gestures and maps to the movement of the endoscope using a dedicated foot interface. So this slide shows the overview of our proposed system. It is a teleoperation system consisting of the slave robotic endoscope and the master foot-controlled interface. During the operation, the operator seated comfortably tightly control the flexible endoscope with their foot based on the camera view. The endoscopic systems can be integrated with commercialized endoscopes. The flexible endoscope used in this study is from Olympus Medical System Corporation. The endoscope can be easily and quickly mounted or dismounted from the robotic system without any modifications, with a few steps. The robotic system includes 3 modules motorizing the endoscope in 4-degree freedoms. They are a bending module controlling the 2-degree freedom bending of the distal tip, a rotation module implementation of the rolling degree freedom of the whole endoscope, and a translational module conducting the in-aft translation of the endoscope. The explosive view of the remote robotic endoscope with 3 modules is shown in this slide. Please see the paper for more detail of the mechanical design. In the operator side, A dedicated foot interface was used as a master device to control the endoscope. The interface prototype with the operator's foot is shown in the left figure. It consists of a base, a mobile plate, a pedal with adjustable foot fixture, and 8 sets of springs and force sensors. The pedal plate supports the leg against gravity in order to minimize human effort. The interface can collect full-degree freedom natural foot positions and force signals with passive haptic feedback and positioning assistance. So this full-degree freedom of foot motions with the foot interface will act as a references for the rotation of the proximal motors, which drive the distal tip of the endoscope. The operator can just imagine their toes as the tip of the endoscope and remote control the sleeve and effector intuitively through isomorphic mapping. Pressing lifting the pedal activated by toe up-down rotation controls the up-down bending of the endoscope. The left-right rotation of the pedal is linked with the left-right bending of the endoscope. Bending in multiple degree freedoms is allowed. For example, lifting and rotating left of the pedal could lead to up-left bending of the endoscope. The left-right swing of the pedal, activated by shank rotation around the side, maps to the rotation of the endoscope. And the forward-backward movement of pedal is linked to the same movement of the endoscope. In addition, the two bending degree freedom can be controlled either by velocity or position based on practical application scenarios. To verify the proposed system, we have conducted an evaluation experiment in which we compared the proposed foot teleoperation with hand teleoperation and direct control. Direct control is the conventional approach for maneuvering the flexible endoscope to perform diagnosis or surgery in hospitals, which is also used in endoscopic robotic systems like Master Wirecast. The hand teleoperation is the most common way to teleoperate robotic system. For example, in Da Vinci system, Flex system, while foot teleoperation is relatively new. For implementation of these three control schemes, hand and foot teleoperation both use a robotic system to remote control the endoscope through hand or foot interfaces respectively. The hand teleoperation setup is using omega-7 interface from fourth dimension. In direct control, the operator manually controls the endoscope at the patient side using his built-in dials. They use one hand to grab the control section and use the fingers of this hand to rotate two control dials. The other hand of the operator should hold the distal end of the endoscope, about 15 to 20 centimeters from the tip. An endoscope locomotion task was tested in this experiment. We recruited 10 participants. They were asked to control the endoscope to 5 special targets one by one sequentially. Each operator was required to perform the task using the hand, foot, teleoperation, and direct control with a randomly assigned sequence. The operation was performed through the same endoscopic camera view for all 3 control schemes. These slides show the result of the operation time in this experiment. As shown in the red figure, both hand and foot teleoperation are more efficient than direct control. Hand teleoperation also needed the least operation time, which is expected as hand is the limb normally used to control objects in everyday life. However, using hand teleoperation does not allow simultaneous control of 3 instruments. The bimanual sequential control may not be that efficient compared to hand-foot operation in 3-hand surgery. In addition, these slides illustrate the average response of 10 participants to the questionnaires. The direct control was felt non-intuitive, in contrast to the hand and foot teleoperation of the robotic system. Foot teleoperation was felt to provide more comfort and less fatigue than direct control, but no significant difference in difficulty and mental effort. The subjects also found hand and foot teleoperation are similarly intuitive, and they felt the foot teleoperation didn't increase the difficulty of the operation or bring more physical or mental effort or discomfort when compared to the hand teleoperation. We also conducted a demo of three-hand surgery, integrating the proposed system with two robotic instruments. In this demo video, an operator used his foot to remote control the flexible endoscope. At the same time, left hand is used to control the grasper, and right hand is used to control a cauterizing hook to perform a surgical cutting task. The endoscope, controlled by foot, provides the visual feedback and enlarges the workspace of the operation, bring the instruments to the target area. In conclusion, this work presented the design and evaluation of a novel foot-controlled robotic endoscope system. The teleoperation system provides full degree freedom control of a flexible endoscope using natural foot gestures. The system can be easily integrated with the commercialized endoscope and other endoscopic robotic systems. The experimental study validated the design and showed the feasibility of the robotic system. All the participants could telemanipulate the endoscope intuitively with their foot and reach the target area without difficulty. The foot teleoperation is more efficient and intuitive than conventional direct control and allows the simultaneous control of three instruments.